Hey, how are you? I'm Jason Lindsay with Hooked on Science. I hope you and your family are safe and well as we continue to battle COVID-19. Speaking of COVID-19, that's the reason why you're watching me virtually this year instead of seeing me in person. We'll eventually get to see each other again, but in the meantime, I wanted to give you a few important tips when it comes to battling coronavirus. Make sure that you keep your fingers away from your eyes, your nose, and your mouth. Cover your sneeze. If you do choose to wear a mask, make sure that you are covering your nose and your mouth and you don't put holes in it. Make sure that you're keeping about 6 feet between you and others, and wash those hands often with warm, soapy water. You'll know that you've washed them enough when you sing the happy birthday song twice. Are you ready for some mind-blowing science? If so, I have some for you. I've connected several cool science experiments to some fairy tales that you are familiar with. In front of me, what you see is a few things that you can grab from around the house so you can try this experiment with the family. I have a glass, not really glass, it's plastic. It's got some water on the inside. I have a pie pan, a toilet paper tube, and an egg. And if you look closely to that egg, I have placed a picture of Humpty Dumpty on the egg, because that's what this experiment is all about. You've heard of Humpty Dumpty before. Humpty Dumpty, what did he do? He sat on a wall. Humpty Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty Dumpty back together again. Our goal with this Humpty Dumpty is to make sure he doesn't break into pieces. So what do I do here? How do I get Humpty Dumpty safely into the glass of water without it breaking? That is the egg. Do you have a hypothesis? That's a good one. Yeah, I like the idea of hitting the pie pan. Did you say that? We're going to do just that. This is all about the laws of motion, really. You have that first law of motion, which says an object at rest, the egg, the toilet paper tube, the pie pan, the glass, is going to stay there until something moves it. Now, once I hit the pie pan, it's going to keep going until something stops it. That's an outside force. So that's the first law of motion. The second law of motion is force equals mass times acceleration. Okay, you're boring me, science guy. Let's make it simple. More mass, more force. And then the third law of motion, for every action, there's an opposite and equal reaction. What I'm going to do, and if you're going to do this, kids, there's a few things you got to follow. That is safety rules. Make sure there's an adult around at all times, wear the appropriate safety gear, and don't eat or drink your science experiments. You can get the complete science guide on how to do this, if I'm going too fast for you, by going to hookedonscience.org. So, we've decided that we're going to hit the pie pan. If you're going to do this, as soon as you feel that pie pan hit the palm of your hand, make sure you stop. Because if you keep going, you're going to knock everything in the floor. Okay? So as soon as you feel that pie pan hit the palm of your hand, you've got to stop. When you apply the force, the pie pan, as well as the toilet paper tube, should go one direction. The egg will resist the change. That's called inertia, the tendency of an object to resist change. And then gravity should pull the egg into the glass of water. Ready for this? Okay. 3, 2, 1. And Humpty Dumpty safely crashed into the water, and he didn't break into a million pieces. Uh-oh, we're going to dump some water out as I pull Humpty Dumpty out here. There he is. He's not broken. Take a closer look at him. Yep, he's all safe. Pretty cool science experiment. Here's a bigger challenge that you can do in the living room. Okay, don't do it in the living room. In the kitchen, maybe outside. Several glasses, like 5 glasses, 5 toilet paper tubes, 1 big gigantic platter, 5 different eggs. Hit the platter. All the eggs should fall into the glasses of water. I once did that on the Today Show. Let's watch. What I have, cups of water underneath, toilet paper tubes on top, a tray in the middle, eggs on top.
Does the water need to be colored?
It does not. It could be any color at all.
Okay.
When I say one, you're going to do this. 3, 2. Look at that.
Wow,
eggs fall right in there.
that's pretty cool.
You hit the pan?
You get to try it. Yes, you hit the pan.
No way this is going to happen.
When you hit the pan, you apply a force. That force causes the pie pan to go one direction in the tube. The egg resists the change. It falls into the water.
How do we not smash the glass?
Okay.
We just don't.
Are you ready?
2, 1.
Jason! You did. Your turn. Hurry, go. 3, 2, 1, go. Now, hold on, Jenna. Jenna, you got to do this. Here you go. 3, 2, 1, go.
Yes!
Time for science. Come on.
Awesome. Science.
That felt good.
The Three Little Pigs is a pretty cool fairy tale adventure. It's all about 3 pigs building 3 different houses, one made of straw, one made of sticks, and one made of bricks. The wolf was not successful at blowing down the house made of bricks. It was just way too strong. I have in front of me something rare. The wolf's windbag! How many breaths will it take me to blow up this 5-foot-long windbag? 3? You know, fairy tales are full of 3s, right? Will it take me 3 breaths? 1 breath? What's your hypothesis? You really think so? I think I can do it in 1 breath, I'll be honest with you. Are you ready? So what is this? Basically, it's a diaper genie bag. I cut off about 5 rulers worth, tied a knot in the end, and I'm going to blow it up with 1 breath. Here I go. Yeah, just 1 breath. That's all it took. Do I have smelly breath like the wolf? Of course not. I have science guy breath. Here's the science behind it. I didn't put my mouth on the bag. That's key. It's important that you put a ruler between your mouth and the bag. And as your breath goes in, it pulls more air in with it, creating a super breath, a wolf breath. And you're able to inflate this pretty quickly. It's amazing. It's jaw-dropping. You can also use a Subway bag, by the way. You can do that for sure with 1 breath. I mean, if I can do 5 rulers worth of a diaper genie bag with 1 breath, you can do a Subway bag. Here's the basic science behind it. I already told you 1 part of it. But what we're doing is we're creating a lower pressure on the inside. It's all about Bernoulli's principle. It says the faster the flow of air, the lower the pressure. So as the fast flow of air goes in the bag, a low pressure system forms. The higher pressure on the outside pushes my air and more air in with it, creating your super breath. You want to see that again? Let me show you. Pull all of my breath out. This is the wolf's windbag. Open it up, 2 fingers, 2 thumbs. About a ruler between my mouth and the bag, and I'm able to blow it up pretty quick, pretty tight, pretty amazing. Here it comes towards you. 3, 2, and 1. There's our cloud as it moves all across the studio here.
Cold. It's a cold cloud.
It is.
I kind of like it.
You feel that? We're filling up the whole studio here with
That's
that. Pretty
crazy.
amazing. Have you ever heard of Jack and the Beanstalk? It's a pretty cool story. Basically, Jack's mom sends him to sell a cow. Instead of getting money, he brings back 5 magic beans. Jack's mom, not so happy. Would your mom be happy? She sends Jack to his room, throws the seeds out the window. Jack's a little upset. He goes to bed, wakes up the next morning, and what does he find growing outside the window? A giant beanstalk. Those beans were magical. He climbs it. At the top, he sees a castle. Pretty cool story. I have Jack's magic foam. It's going to grow, 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 and grow. So inside of these containers, juices from those magic beans. Okay, not really. It's all about matter. Matter is anything that takes up space and has mass. I know matter can exist in 5 states, but we mainly focus on 3, solid, liquid, gas. You know all about those states of matter. You encounter them each and every day. Breathe in deep for me. What do you breathe into your lungs? A gas. Sometimes you create a smelly gas when you pass gas, right? Okay, let's skip over that. But when it comes to the other 2 states of matter, we have solids like this table, this container. Okay. And then we have liquids, apple juice, orange juice, toilet water, so on. These liquids are very viscous, meaning they're very thick. We have a dark one and we have a light one. I'm going to pour them into my cup. Now, my cup is a solid, but my cup right now is filled full of air. I'm going to replace some of that air with these 2 liquids. We're going to mix these 2 ingredients together and we're going to get something new. Jack's magic foam. It's going to keep growing and growing and growing, bust through the ceiling and take me to a castle, right? Okay, maybe not. Still be fun though, right? I'm going to pour the dark liquid in first. Again, very viscous, thick, kind of like pancake syrup that you put on your pancake. That one's dark. We can describe matter by its observable properties. What does it look like, smell like? Obviously, I wouldn't taste it. Does it sound like anything? What? Yeah? Third grade boys smell like cheese? Okay. They really don't. It's fifth grade boys. Come on. Pour that in there. So when we mix these two together, we're going to get something new. We call that a chemical change when we get something new. Physical change, you don't get anything new. Let's look, see if anything at all happened. You'll notice the color of the liquid went from the dark and light color to more of a creamy color now. I'm rapidly mixing this up, rapidly, meaning fast. Anything happening yet? Jack's magic foam growing? Oh no. Oh no, it's growing. It's gonna keep growing. Here it goes. Oh no. Are you seeing that? Amazing. Okay, will it bust through my ceiling, take me to a magical castle somewhere? No, it won't. But still, that thing, pretty awesome. We had a chemical reaction happen, and not only is it a chemical reaction, but it's also an exothermic reaction. Let's say that together. Exothermic, meaning it gives off heat. The cup is really hot. Believe me, I wish I was there so you could feel it. Thank you, COVID-19, right? One day we'll get back together. But the bottom line is it got super hot. The opposite of an exothermic reaction is an endothermic reaction. Again, pretty cool. Chemical reaction, gives off some heat. We went from a liquid to a solid. Liquid to a solid. Liquid to a, you got it, solid. Amazing. Oh, let me show you a physical reaction really fast. Still foam. Whether I break it or not, we don't get anything new. By the way, this is the same kind of stuff that mom and dad might use in the wintertime, or for that matter, even the summertime to keep the cold air out or the cold air in. They put it around the door. They may put it around the window. They get it at their local hardware store. Same kind of foam. I just slowed down that reaction by mixing together those two ingredients rapidly, but it doesn't form as quickly as it might out of that can as your parents spray it in the door facing or around the windowsill. Say, go science. Go science! We'll pour that in there. And
gosh.
There we go. Look at that.
Oh, that was cool. That was
Pretty
so
amazing,
cool.
right? Yeah.
That was really cool.
Put your hands right above it, but please
Is it
do
hot?
not touch it. Please do not touch it. Just put your hands right above
Well,
it, and you'll feel the heat coming from it.
Yeah.
That's an exothermic reaction. Goldilocks and the Three Bears. It's a fairy tale we've all heard about. You know the story. Goldilocks sits in 3 chairs. She also does some other things, but we're going to focus on the chair because I have Little Bear's chair. Look how little it is. Little Bear sits in this chair. Okay, not for real. But we know that when Goldilocks tried out Little Bear's chair, what happened to it? It broke. This chair, I'm going to balance on the palm of my hand, and it should stay in my hand and not fall to the floor. It's all about center of gravity. Gravity is going to pull down on this in all directions. In addition to that, air, stuff we're breathing in, is going to push against the sides of the chair. Once I find the center of balance, center of gravity, it should balance on one leg. Wonder if Goldilocks would break this chair. Here we go. Let's try it. 3, 2, 1, go. Okay. Almost broke Little Bear's chair. Okay, we're going to count together to see how long I can keep this balance in the palm of my hand. Are you ready? 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and almost broke Little Bear's chair again. Pretty cool experiment. Obviously, this is not really Little Bear's chair, but you get the point. It's awesome. You can try the experiment at home with a broom. You should be able to balance a broom in the palm of your hand the same way. Just take the actual part of the broom that you would sweep with, not where the bristles are, turn it upside down, put the bristles toward the air, and you should be able to balance it. What about a baseball bat? You've probably done that as well. Same concept. Let's try this one more time. Let's see. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I drop it. Let me show you. I'm going to take this, and you'll see how I built this. Basically, I have a water bottle I've dissected, a wash rag at the end. I'm going to dip it inside of my bubble solution here.
Okay.
Then I'm going to step over here and gently blow into the water bottle.
Whoa!
Oh,
look,
my kids
wait,
would
look.
love this.
Here, you do it, Kel.
Yes.
Here, get in
Oh my
there.
God, my kids are obsessed with this.
We have a bubbles
Yes,
tank.
she loves
Go ahead and
bubbles.
get them there, ladies, and let me get out of your way. What you're going to do is gently blow into the bottle. We have the wash rag, which has tiny holes in it, and those tiny holes are acting as bubble wands.
Mine
Look
was
at
the
that.
saddest
Pretty
bubble
amazing.
thing
Look
ever.
at Hoda's over here.
Hoda, yours is amazing.
Isn't that pretty cool? Have you ever heard of Rapunzel? Remember, she's that fairy tale character that grew the super long hair. A witch locked Rapunzel into the tower of a castle. She grew her hair out very, very long, and one day a prince came by on his horse and saved Rapunzel from the witch. Inside of here, you hear them. It's Rapunzel's beads, as long as her hair, and they do something magical. I'm going to take the tip of these beads and I'm going to throw them out of the cup. I want you to watch as the beads resist the change. Notice how they create an arc. 3, 2, 1. See that? Let's try it again. I'm going to bend down, stuff my beads back into my cup, and we'll try it again. First and foremost, the beads, while they're in the cup, they have potential energy. Basically, that's stored energy. Once I release the beads from the cup, potential energy is converted from stored energy to energy of motion, known as kinetic energy. Along the way, the beads try to resist the change, basically gravity pulling them out of the cup, and they start to arc at the top, especially near the end. Let's watch again. 3, 2, 1. There we go. Amazing.
Incredible.
Can you say science is awesome?
Science is awesome.
Pretty cool.
Ah, the best in the world at making tablecloths disappear.
Pour that in there, and there we go. Look at that.
Oh, that was cool. That was
Pretty
so
amazing,
cool.
right? Yeah.
That was really cool.
What's up with your hair there?
Mad scientist time.
Hold on, I'll fix it for you. I got a little slobber
Don't
here.
touch me.
And you'll know our foam reaction. You'll see the red and the blue. The water bottle.
Whoa!
Oh, my kids
wait,
would
look.
love this.
Here, you do it, Kel.
Yes.
Here, get in
Oh my
there.
God, my kids are obsessed with
We
bubbles.
have a bubbles
Yes,
tank.
she loves
Go ahead and get
bubbles.
them there, ladies, and let me get out of your way. What you're going to do is gently blow into the bottle. We have the wash rag, which has tiny holes in it, and those tiny holes are acting as bubble
mine was like
wands.
mine
Look
was
at
the
that.
saddest
Pretty
bubble
amazing.
thing
Look
ever.
at Hoda's over here.
Hoda, yours is amazing.
Isn't that pretty cool? 2, 1. Oh, are you okay, Jenna?
Yes.
Your hair looks even more beautiful.
Remember you said you wanted to be Blair from Facts of Life? That
Yeah,
was
will
kind
you
of
try it again?
Yeah.
Try it again. Hold on. Hold on.
Slower.
Just
Yeah,
slower.
ready, go.
How about you? Whoa! Hey, it's Jason Lindsay with Hooked on Science. I wanted to share with you one of my favorite books that I like to read to kids across America. It's called The Three Little Pigs Sledding Adventure. It's oozing with science, and bottom line, it's just a cool book. One snowy winter day, the three little pigs went outside to play. This is good snow for sledding, said the first little pig. Really good, said the second little pig. Absolutely perfect, said the third little pig. The adventure only gets better. But before they could go sledding, they had to build some sleds. The first little pig didn't much care what his sled looked like, and he was in a hurry to be done. So he made it out of straw. The second little pig made his sled out of sticks. Each stick had to be just the right length, so it took him a little bit longer to finish. The third little pig never did anything without thinking it through very carefully. After a while, he decided to make his sled out of bricks. Not surprisingly, he took the longest time of all. When everyone was ready, they set off for the biggest, coolest hill around. This will be fun, said the first little pig. A lot of fun, said the second little pig. The most fun ever, said the third little pig. But the pigs were not out alone that day. A wolf was there too, passing through the woods. He was not just a big wolf. He was not just a bad wolf. He was a big bad wolf, the very worst kind ever. What do we have here? The wolf said to himself, spotting the pigs in the distance. What luck! 3 little pigs will make a very fine meal. Then the wolf yawned lazily. He didn't want to have to chase squealing pigs through the snow. That would be too much work. But what could he do instead? Clearly the pigs were going to sled down the hill. If he waited in hiding, he could catch them easily at the bottom. Right? Let's see what happens. The first little pig reached the top of the hill before the others because his sled was so light. Here I go, he shouted, jumping on the sled made of straw. Whee! Cried the first little pig happily as he went down the hill. He had only barely reached the bottom when the wolf jumped out in front of him. I have you now, he cried, stopping the sled. And before the first little pig could even let out a squeal, the wolf had stuffed him in a sack. 1 down and 2 to go, muttered the wolf. Then he dragged the sack back to his hiding place. What about pig number 2? The second little pig reached the top of the hill next. He could see that the first little pig had gone down ahead of him. But where was he now? What a long ride he must have had, said the second little pig. Now it's my turn, he shouted, jumping on the sled made of sticks. Whee! Cried the second little pig, sledding down the hill. What might happen? At the bottom, the wolf jumped out again. I have you now, he said. But the second little pig's sled was a little harder to stop and almost knocked the wolf down. Almost, but not quite. So the wolf stuffed the second little pig in the sack with the first. 2 down and how many to go? Just 1 left, muttered the wolf. Then he dragged the sack back to his hiding place. Will the third little pig save the day? By this time, the third little pig had finally reached the top of the hill. It had taken him a while because his sled was so heavy. He knew that the other little pigs had gone down ahead of him. But where were they now? What a long ride they must have had, said the third little pig. Now it's my turn, he shouted, jumping on the sled made of bricks. Whee! Cried the third little pig, racing down the hill. Now remember, it took him a little bit longer to engineer his sled. It has more mass. What's going to happen? From his hiding place, the wolf looked out. He licked his lips hungrily. It won't be long now, he said. 3 little pigs will be the best meal of all. As the third little pig neared the bottom, the wolf jumped out. You can't escape me, he cried, and he waited for the sled to reach him. Oh no, you got to see this. Crash! The third little pig and his brick sled plowed right into the wolf, knocking him high into the air, and when he came down, he landed on his head. For a moment, the wolf just sat in the snow, blinking his eyes. The third little pig wasted no time freeing the others. Then all three of them started pushing the sled made of bricks. Time to go, they said together, and off they went as fast as they could. Come back here, cried the wolf, who was coming to his senses. He tried to catch up, huffing and puffing all the way, but it was too late. The three little pigs soon left him far behind. That was close, said the first little pig. Really close, said the second little pig. Closer than I ever want to get again, said the third little pig. And they sledded all the way home just in time for supper. What's one of your favorite books that you like to read? Let me know. And don't forget, check out hookedonscience.org for the free experiment of the week.
It would not be winter without snow and ice and everything nice.
So we're going to show you how to create your own.
I like it.
Here with a few tricks up his sleeve is Mr. Science himself, Jason Lindsay.
Hello, Jason.
Welcome back. You about killed us last time.
Oh, you survived,
That's why I
right?
got the
Yeah.
most underwhelming song. Like Jason
Lindsay.
So this,
Wow us with science.
what we
gotta get the
have
remix.
here
Yeah.
is a hand warmer. You use these in the wintertime
Sure.
to keep your hands warm. We're
Yeah.
going to create a hot ice sculpture
Let's
with
see
them.
it.
Okay.
You'll notice I already have a catalyst there. Here is the hand warmer.
Careful.
In order to prevent this from happening quickly, we're going to put some vinegar on here. I'm going to dip my scissors in, and then I'm going to cut the top. Now, this one could be tricky for those of you trying this one at home, and you can
Okay.
try it at home. It's just
Okay.
you've got to be very careful. So watch as I pour this on here. You'll notice the reaction starting to take place, and it starts to grow and grow and grow and grow and grow and grow.
What?
Science!
Pretty amazing. So go ahead and touch the side. It's okay. It's safe.
Touch it?
Small chance your fingernails will pop off. Joking, joking, joking. It's hot, correct?
That's crazy, yeah.
That's an exothermic reaction that's happening, giving up
That's
heat.
hot ice. Show us some snow. Make
So
it snow.
it may not snow all the time, but you can have your own snow
Okay.
on Christmas. It's
Okay.
called instant snow. You'll notice the powder on the inside.
Yes.
It's all about atoms, basically, which
Okay.
is the smallest piece of matter. And basically what's going to happen is you have the atoms, then you have the molecules, then you have the polymers. Bored yet?
Show us.
Let's just
Show
do the
us.
science.
Yes.
Pour that water in there as
Do
fast
it,
as you can.
Cena,
I'll do it.
Cena, do it.
Go
do
ahead,
it.
3, 2,
Science.
1, and watch what happens. Give it a few seconds. It starts to absorb, and look at that. Pretty amazing. Let's do it on a bigger
Cena,
scale. I'm sorry,
do
what was
it.
your question?
I'll do it.
Never mind. What'd you have in there? What the-
It's an instant snow powder. As fast as you can.
Science!
Cena. Oh,
Whoa.
good
Yes.
gravy.
Yes.
Okay.
Science!
Wow.
So watch. Now he lost some of our water, but it's growing. Take a look
Look
at
at
that.
that.
You can see the instant snow right there. Go ahead and touch it.
We're gonna
It's
be
not going to
overrun.
hurt
Is
you.
it cold?
It's not. It's kind of cold. We do have
Oh
instead of
my
an exothermic,
gosh.
endothermic.
That is awesome.
You just cannot create a
You know,
snowball
be
with that one.
styrofoam.
You did not.
Be patient. Be patient.
No, you didn't.
Keep going
No, you
to the
didn't.
top. Keep
No, you
going.
didn't.
Keep going.
Oh.
Here we go. I've got to help
Okay.
out just a little bit
All right,
as
the
I
newly
push.
crowned winner of The Voice is going to be up next.
Yes, Spring Cartelli sings first right after this.
How is that possible? Hey! Look how he did that. How is that possible?
Remember this fairy tale? Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his what? Crown, and Jill came tumbling after. I have Jack and Jill's unspillable cup of water. Inside of this styrofoam cup, I have some water. Just to prove that to you, I'm going to pour this water right into the other cup. I'm going to set this cup in the middle of this board that has 2 strings attached to it. And next, I'm going to spin this around, and it should not spill. Knock on wood. It's all about a force called centripetal force. That force will keep my water from spilling everywhere. 3, 2, 1. It didn't spill out. Look, it's not glued either. The science is simple. Basically, I told you it was about centripetal force. Basically, you'll notice how I'm going in a circle here. What happens is that force is pulling the water toward the board, and it keeps it from spilling out everywhere. Now, if I were to go slow or stop, what do you think might happen? You're right, it would spill everywhere. Okay, let's try this again. Kids, if you're going to do this at home, do it in the living room, near the TV, right? 3, oh no, 2, 1. Water still in the cup? I'll take a drink. need some cold water after that one. I hope you and your family stay safe this summer. Don't forget to check out hookedonscience.org for a bunch of science videos and experiments and free science games and more. Don't forget to follow Hooked on Science on Facebook and Instagram. Just look for Hooked on Science.